Okay, when last we met, we were working on this program. This program was going to allow us to input all of our scores for the class, and it was going to figure out our average. So where we had left off, we made a function to compute the test average. So the test average, we sent it the 3 test scores, it found the average, and it returned it. We made a function to compute the final average. So the final average, we had to send it test average, lab average, project average, and quiz average, and the score on the final exam. And then that function took the lab average times 0.25, the project average times 0.1, so on and so forth. It computed the final average that you would have in the course, and it returns it. Then we made a char function to return a letter grade. So this function accepted our total average, and based on the total average, it computed the letter grade. And we got a little lazy. We decided we were only going to get an A or a B in the course. We were running out of time, so we didn't write the C, D, F stuff. Yeah, you don't get an A or a B, you know. And then finally, we created a void function to print everything. So the void function accepted lab average, and it prints out the lab average. And it accepts the quiz average, or the project average, prints the project average, so on and so forth. This function just prints everything, and it gets all done. What we hadn't done at this point, we'd written all the functions to do all this stuff. We had absolutely nothing in our void main. So right now, if I run this program, it does absolutely nothing because there's nothing in the void main. So let's finish this one. What do we need in the void main? Instructions. All right, so see out. You will enter all of your scores for this class. This program will compute your final average and grade. All right, so there's the instructions. What's next? Some CN statements. What are they going to see in? All right, before we can see in those, we need something else. That's true too. Something even before that. We need variable names to be able to store all that stuff, don't we? Okay. What kind of variable names do we need? What kind of variables do we need, and what do we need? What is the person going to enter? So we have 3 test scores, a lab average, project average, quiz average, not test average. Test average will be computed. Final exam grade. And why did I put some on one hand and some on the other? Some are ints and some are doubles. The test scores, the 4 test scores, the 3 exams plus the final, those are all integers, aren't they? The averages, the quiz average, those are floats or doubles. So we have 2 different types of variables here. Okay, so we need integer variables. What do we want to call them? I don't want to use test 1 and test 2 because I'm using those in my function names. Yeah. So how about exam 1, exam 2, exam 3, fail 1, fail 2, and how about exam final? Okay, so those are those variables that we need. And then we needed some float variables. What should I call those? I haven't used QAV yet, have I? Oh, I used QAV here.
Wow.
So QUAV. LAAV for lab average, going with the same. And then PRAV for project average. See out. Enter your 3 exam scores. Scan. Exam 1. Exam 2. Exam 3. Alright, so I put in the 3 test scores. Out. Enter your score on the final. Scan. Exam final, we called that. And then finally see out. Enter your quiz average, lab average, and project average. Do those all in one line, I guess. CN, quiz average, lab average, project average. Oops. Got the shift button there. Doesn't like those. Okay, so I think we're almost ready to go. So we've declared the variables we need. The person has entered all their scores in. Now what do we do? Which function do we run first? The first thing we need to find is the test average. What are we going to do with that test average? Are we going to print it? Are we going to store it? Use it in something else? We need to store it. Why do we need to store it? Because we need to send it to our final average function. All right, so that tells me I need another variable. That sounds like it's going to be a float variable. Exam av. Okay. Exam av. Equals. How do I call the function that does the test averaging for me?
Test av.
I write the word test av, and then I put a parenthesis, and then I send it the variables I want to send it. Exam 1, exam 2, and exam 3. So what this is going to do, it's going to see that I'm calling this function test av. It's going to jump down here. Exam 1 will have the same value as test 1. Exam 2 will have the same value as test 2. Exam 3 will have the same value as test 3. It'll add those up, divide by 3, make it a decimal for me, and send it back and store it in exam average. So I'll average my 3 exams and store it right there. Now that we know the test average, what do we want to, or the exam average, what do we want to do? We want to figure out our final average. Do we need to store our final average, or are we just going to print it? We need to store it because we later on need to send that down here to figure out our letter grade. So again, I think we need another variable called final av. I'm using final av as a function name. Final grade.
I like 5.
5. How about overall av? You use the point. All right. So now we'll compute the overall average. Overall av equals. I do want overall to be a float, so I better put it in the right spot. Why does overall need to be a float, not an integer? Be consistent. Overall av. All right. So overall av equals. I call this function called final av. And then what do I send to it? Test average, which is our exam av. The next variable it takes is lab average, and the main lab average is LAVE, L-A-A-V-E. The next variable it needs is project average, which we called in our main P-R-A-V-E. Next is quiz average, Q-U-A-V-E. Wave. And then final score. So it needs the score on the final. We call that exam final. All right, so very similar to calling the exam av, this function is going to send all those things into our new function. It's going to use this formula to compute our average, send it back, store it in overall av. Almost done. What's left? Figure out the letter grade, and then after we figure out the letter grade, we print stuff. Okay, so when I figure out this letter grade, am I printing it or am I storing it? I've got to store it because I've got to send that to my function that prints the stuff for me. All right, so we need another variable. What kind of variable is this? It's a character variable. What do we want to call it? Letter. Oh, I think I used letter already. I don't know what I got to call it. Oh, I used letter grade. I used letter down there somewhere. Yep, I used letter down there.
Grade letter.
Grade letter.
Grade letter.
Grade letter. So grade letter equals, I call my program called letter grade, my function called letter grade, and I send it. What do I send it? Overall av. Finally, I think I have everything I need at this point. I'm ready to print. So I run my program print stuff. And then it does tell me what stuff I need to send, in what order. So I need to send lab average, that's L-A-A-V-E. Project average is P-R-A-V-E. Q average is Q-U-A-V-E. Test average, we call that exam av. Final score, exam final. Final av, we called overall av. And finally, grade letter. Lots of variables. Run it. Okay. Debug. Start without debug. Running, hopefully. All right, what do we get in our 3 exams?
80, 75, I think.
80, 75, and 90. What was your score on the final?
60.
60. Enter your quiz average. 100. Lab average. 50. Project average. 70. So your lab average was 50, your project average was 70, your quiz score was 100, your test average was 81.66666 going forever, your score in the final was a 60, your final average would therefore turn out to be a 69, which means you get an F in the course.
Congratulations. Yeah, that's a great. For the passing grade. These three get degrees.
Questions on that? Okay, so this is actually pretty common. What I mean by that is void main usually in a lot of programs doesn't have a whole lot of stuff in it. All the stuff, all the work is done within the functions. So pretty much what you'll see in your void main, this probably wouldn't even be in your void main. You would probably create a function called directions and have that be done outside. Pretty much the only thing you would see in your void main is declare variables, get the variables, and then run your functions on all your stuff to do all your calculations and all your other things. So void main tends to be a very, very short thing. Where the length is, all the work is down here in all of your functions. So well-written programs tend to be very modularized. You have different modules, different little functions that do all the work. The main does very little. What would be wonderful, actually, would be if you could put comments right up here, right in your protocols, so that when I go to read and I'm reading from top to bottom, I can see that exactly what these functions are going to do before you even define them. So that would be ideal, that you put the documentation right here, right at your function prototypes, so that I know what you think each of your function is going to do. Other questions? Okay, let's save all of this. Okay, so all the functions that we have written up to this point either return exactly one value or they return no values, correct? And look at all these functions that we have here. These three functions all returned exactly one value. And this function right here, this was just a printing function, this one returned nothing. In C++, you can write functions that return multiple values. Why might you want to return multiple values? It might be nice to have one function instead of three. For example, some of the first functions we wrote back a couple weeks ago, we created a program that found the slope of a line and found the y-intercept of a line. And we did that in two different functions, didn't we? We had one function to compute the slope, one function to compute the y-intercept. We could do that and return both the slope and y-intercept in one function, rather than having to write two different functions. The question is, how do you do that? I'm going to delete all this, and we'll start over. Okay, so let's do exactly that. Let's create a function that's going to compute the slope, compute the y-intercept, and send them both back. To return multiple variables, it's a void function, which seems weird because usually void returns nothing, but you also use void to return multiple. What do we want to call this function? No, I don't know. Line function, because what is this doing for us? It's finding the slope and intercept of a line. All right, I'm just going to call it line then. Line. If we want to find the slope and the y-intercept, what do we need to send it? 2 points. All right, so we're going to have, are those points going to be doubles or ints or floats? Probably float. All right, so float. X1, so we're going to use bad variable names? Okay. I'm going to be lazy today to save time. So float x1, float y1, float x2, float, yeah, still not good. Okay, so those are the variables we're going to send it. We're going to send it x1, y1, x2, y2. In this same line, we also write the variables we want it to return. And the way you do that, you write float, and then you put that symbol. What's that symbol called? Ampersand. You put an ampersand, and then you give it a name, like slope, comma, float, ampersand, y-int. Okay, so what we've done is we've declared 2 types of variables, 2 types of inputs. These are called value parameters, because when we run this function, it sends those values. These 2, on the other hand, these are called reference parameters. What's going to happen when I call this function? It's not going to send the number to the function. It's actually going to send the memory location. It's going to tell the function, go look at the memory location that has this variable named slope. And so what will happen if slope changes within the function, it will change the memory location, so it will change it back in the main also. So that's the difference. These are called value parameters because it's just sending whatever value is stored in the variable. These, on the other hand, are called reference parameters because you send a memory reference to the function. Finds the memory location, changes the memory location, so when you jump back to the main, since it changed the memory, it's changed in the main and changed in the function. Okay, so that's how you return multiple things. To return multiple things, you put what variable type you want, an ampersand, and then give it the name. And that sends the memory location rather than the original thing. All right, so we're going to need this. Like so. I'm sending it x1, y1, x2, y2. If I send it all those things, how do I find the slope? All right, so I'm going to have a formula here that says slope equals y2 minus y1 over x2 minus x1. Cool. So that computes the slope for me. How do I find the y-intercept? Use a point in the slope, and I solve for the b number. It turns out to be y1 minus slope times x1. Of course, I could have used y2 and x2 also. Okay. So there's my function that's going to compute slope and compute y-intercept and send them both back to the main. It'll send both of them back in one shot. In my main, what do I need? Well, I need to eventually call the function. Before I do all that, I need variables and I need the user to input information, don't I? All right, so I think I need 6 float variables. What are my float variables? X val 1, X val 2, Y val 1, Y val 2. I don't want to use slope because I'm using it here. How about M val, sticking with the val theme, and B val. Works as long as I use that again. All right. Okay, so normally we would put directions in. Again, in the interest of time, I'm going to blow off directions. So we would put in Cout, enter the first point, Cn, X val 1, and X val 2. And again, I'm not giving good directions, but that's all right, because I'm the only one who's ever going to use this program. Ooh, I don't want X val 1, X val 2. Y val 1. And then we do the same thing over again, except we enter the second point, right? Oops. Work on crazy here. So the user has now entered all the X numbers and Y numbers that we need. What do we do next? We call the line function. What do we send to line? X val 1, Y val 1, X val 2, Y val 2, M val, and B val. Okay, so here's what's going to happen. It's going to take these four numbers, whatever numbers we type into the keyboard, it's going to send those numbers to the function. So it'll send them in as x1, y1, x2, y2. It'll compute this thing called slope. Slope and M val share the same memory location. So when it changes slope inside this function, it also changes M val in the main. That's how that works. M val and slope have exactly the same memory location. So when memory is changed in the function, memory is changed in the main. Same thing happens with B val and Y int. When it computes Y int, it changes the value in the memory location for Y int, but Y int and B val point to the exact same memory location. So now B val is going to have the same value as Y int. The last thing we would have to do is just print. Cout Y equals slope times x plus, oh, I don't want slope there, I want M val. That's my variable in the main. And B val. And again, I'm being lazy. I am not going to concern myself about printing a 1x or a plus -3. We've done that before. You guys know how to fix all that now. I'm not worried about that. I just want to talk about how you send multiple things. Let's try it. What's the first point? Read 2. What's the second point?
7.
Nope, it's 0, 0. That way I know what the y-intercept. Oh, okay, we'll go 0, 1, I guess. So I know the b number should be 1, and what should my slope be? Well, if I go from 0, 1 to 3, 2, I'm going up 1 and over 3, so my slope should be 1/3. Y equals 0.3333x, that looks like 1/3 plus 1. Get the right answer. Questions on that? Questions about how to send multiple variables and return multiple variables?
So you're not really returning that.
Correct.
You're just modifying the network.
Correct. Technically, when you have a function that changes multiple variables in the main, you're absolutely right. You don't return anything. This function doesn't return anything because it's a void function. What you're really doing is exactly what you said. Slope and yint and mval and bval are sharing memory locations. So when I change the memory location in one, it changes the value in the other.
Did you do this with a single reference variable?
What do you mean?
Like if we only wanted to do slope and not do the yint, could we do that and have the, or does there have to be multiple?
There does not have to be multiple. You could. What Alex is asking is,
So we can do what we did before, but with this one.
yes. So we could call this a void function and only have float ampersand slope and only change the memory for slope and have that go back and forth. Now that's kind of unusual. If you're only changing one value, then usually you have it do a return. And you wouldn't call this a void function, you would call it a float function and have it return the one value called slope. But yes, it would work. It would work to have a void function, have it only share one memory location instead of two, and therefore only change one value in the main. It does work, just unusual to do it that way. Other questions? Yes. I could right here, let's say right here, I said mval equals 15. That changes the value of mval in the main. And what it really does when I do that is it writes the number 15 in the memory location for mval. Pretty much the same thing happens when I run this line. When I run this line right here, it changes the value of mval by changing its value where it's stored in memory. So yeah, it's really kind of the same thing, except this line is actually changing two variables at the same time. It's changing mval and bval, which there's no way to do that in a standard line like that. I can't change mval and bval in one line. Not in a way that I can think of anyway.
Why don't we change the variables in one? It's a change of, not change of the same number, but change, it's just make it so that in multiple lines.
Well, it's making it so that we don't have to do multiple functions. So we can change both variables at the same time. Maybe you don't want to. Maybe for you it would be cleaner to write two separate functions, one that computes the slope and one that computes the y-intercept. But you can do it at once also. Sometimes it's convenient to have functions that return multiple values rather than having multiple functions. For example, you might have a function that takes a point in XY notation and returns the same point in polar notation. Have you used polar notation before? Oh, all right. You got to do a little math there. No, you don't do it in Calc 3. Okay, so most of the time in math, in most of the math classes you've taken anyway, if we draw a point here, we might call this the point, I'm going to make it easy on myself to start with, we might call this the point 3,3. If I call that the 0.33, what does that mean? It means I started here, I went 3 to the right, and then I went 3 up. A different way of labeling points is to have a point here. Consider this little line segment, and we label it as R and theta, where R is the distance from the origin to where this ends, and theta is that angle. And that's called polar form. So this is called rectangular when you give it X and Y. Polar, you tell somebody R and theta. You tell them the radius and the angle. This is also, the rectangular is also called Cartesian. Yes. Named after? Close. Rene Descartes was his name. Carte, C-A-R-T-E, Cartesian. Yeah, of course. Carson? Yeah. Anyway, if I know the point 3, 3 in rectangular form, how do I find the radius? That's your distance formula. That's the old Pythagorean theorem, isn't it? This would be 3. This would be 3. Say that again. Yes, because r squared would be x squared plus y squared. So that's your old Pythagorean theorem. So r is going to be the square root of x squared plus y squared, which in this case would be the square root of 9 plus 9, square root of 18, and you said that's 3 square roots of 2. Okay. And then, how would you find theta? You use your vast knowledge of trigonometry. Correct. Uh-oh. All right, so I know the opposite, I know the adjacent, and I want to try to find the angle. What uses opposite and adjacent? Tangent. So tangent of theta would be y over x. So theta is arc tangent of y over x. So, if I give you a point x comma y, to convert it to r and theta, we would have two formulas. R is the square root of x squared plus y squared, and theta would be the arc tangent of y over x. So if I were writing a program that a person entered a point in rectangular form and I wanted them to get the point in polar form, I would probably write a function that had two value parameters. It would send x and y, and have two reference parameters would return r and theta. And I would do that in one function. I would have one function that computes both r and theta and send them both back at once. So quite often it makes sense to return multiple things at the same time rather than writing two different functions to return two different things. Now, this, unfortunately, only works if your angle is either in quadrant 1 or quadrant 4. If it's in quadrant 2 or 3, you got to do more math.
Is polar form degrees or radians?
It could be either. If I'm using C++ and I write this code, by default it's going to be radians. I could convert it to degrees if I wanted to. So it would depend on what you want for an answer, how you want your answer to be. You could ask the person running the program, or you could be generous and give both. Wouldn't be hard to just be two separate C out statements, right? The angle, the radius is, and give the R, and then the angle is something in radians or something else in degrees. You could give both if you wanted to make it easy on the person, I suppose. Questions on that? How come this only works if you're dealing in quadrant 1 or quadrant 4? I mean, I can draw a point in quadrant 2, right? Here it is. And then I can talk about the r and I can talk about the theta. I mean, we can have points in quadrant 2 and quadrant 3. But if I use that as my code, it's only ever going to give me an answer in quadrant 1 or 4. It won't give me the right answer. How come?
Because the domain of arctan is only, that's the domain of arctan. It doesn't apply to.
Right idea, wrong word. It's the range of arctan. Arctan only ever gives answers in quadrants 1 and 4. And it has to do with, in order to talk about an inverse function, you need the original function to be 1 to 1, and tangent is 1 to 1 in quadrants 1 and 4. So how would I get my answer over here in quadrant 2? Yeah, you have to use my reference angle thing. So what I would need to do is I would need to check if the x number is negative. If the x number is negative, then I'm going to be over here in quadrant 2 or quadrant 3, aren't I? Or I'm sorry, yeah, quadrant 2 or quadrant 3. So what I would have to do is actually going to give me, if I'm in quadrant 2, when I run that arctan, it's actually going to give me that angle. So I would need a little test. If x is negative, compute this arctan thing, but then add, more than 90, 180 degrees, or pi over 1, just pi, 180 degrees is pi. And the same thing would happen if I'm down here in quadrant 4. It would give me or quadrant 3. It would give me the answer in quadrant 1, and I'd have to add half a rotation. So you would lead the little if statement. If x is negative, run this formula, and then add either 180 degrees or add pi radians, depending on what you want. Well, that seems pretty short. Let's write it. What the heck? We don't have time. I was going to do recursive functions today. We don't have time to start that anyway. I guess I'll save this one. Okay, let's see. I want to save some of this because we need an x1 val and we need a y1 val, don't we? We need those still. I don't need slope, I don't need y2 val, I don't need m val. But what do I need? We're going to take x and y and turn it into r and theta, so I think I need an r val and theta. Enter the point. I still want to do that. I don't need to enter the second point. And then I don't think I want the rest of that stuff. And I don't think I want this function. Rather, I want a different one. So we'll give them all that. All right, so there's what we need in our main so far. We need to enter a point, x1, y1, and we'll have it. Okay. Once again, this is going to be a void function because it's going to send several things back to the main. What do we want to call it? Polar, because it's converting to polar form. Okay. What value parameters do we need? What numbers do we need to send it? So we need an int, not an int, float, x1, float, y1. So we need to send it the x value and the y value. And what do we want to have it send back to us? Radius. So that would be float and radius. And what else do we want to return to us? Float and angle. I'll just call it angle since I already used theta down below. radius. That one's the easy one. Radius equals square root of x1 squared plus, oops, cap block again, plus y1 squared. I still better call C math? Yep, you're right. I need C math for the square root. CX math, no, just C math. And then to find angle, I do arc tangent of y over x. Oh, y1 over x1. Better give it the right names. But then I got to make sure I'm in the right quadrant. So if x1 is negative, angle equals angle plus 3.1415927. I'm just going to work in radians, I guess. See out. R val. Spaces. I'm missing one thing. What am I missing? What do I need to do before I print my R value and my theta? I better call my function that figures them out for me. So x val. Y val 1. Y val theta. Enter the point. All right, so give me a point that we know. 3, 3. Well, do we know what the square root of 18 is, though?
5.
But it's going to give me a decimal. It's not going to give me 3 root 2.
1.41. So that times 5.
3, 4.
Do I know the square? Do I know 2 square root? Do I know 5 square roots of 2?
What's an easy one?
3, 4.
What's an easy one?
0.
Well, 0, 0 is a very easy one.
Go with 1, 1. We know that one.
Well, I know the angle for 1, 1 is 45 degrees. And I know the radius would be
like 1.41.
square root of 2. All right, so let's try 1, 1. So that should be 1.414. That's the square root of 2. That's the radius. That's right. And is 45 degrees 0.785398 radians?
Oh, what are you doing?
See, I would have gone with something like 3, 0. Because how far is 3, 0 from the origin? 3, and what's the angle? 0. Hey, 3, 0 is the same as 3, 0.
That's genius.
That's genius. I thought so. Or I might have gone with 0, 3, which is 3 straight up, and it's half a pi, which is about 1.57. So, seems to be working. All right, so that's how you pass multiple variables. Tomorrow or Thursday, we will talk about recursive functions, whatever those are.